Okay, for today, we're going to go a little bit different. We're actually going to skip around a little bit in our books. Just for the record, our homework is page 411 and 412. We'll get to that at the end of the class. Today, we're working on composing, decomposing numeric and algebraic equations and substituting values in equations to determine whether they make the equation true, then construct and analyze equations using properties of equality. This is actually the most important part of today's lesson. So that's where we're going to start. That's why I want you guys to start out on page 406 for today. Okay? Because this is where we're going to actually get some of our definitions. If you have highlighters, get those out. If you don't have highlighters, get some type of marking pen so that you can highlight these definitions. Okay, now that you have your highlighters, let's take a look at this. Our first definition. The addition property of equality states that if two values A and B are equal, when you add the same value C to each, the sums are equal. It'll make more sense as we start putting numbers in it. Just understand this is your generic definitions. The subtraction property of equality is very similar, except that when you subtract the same value C from equal values A and B, the differences are equal. In other words, all it's saying is if I have an equation where one side equals the other, and I add the same amount to both sides, my equation stays true. Same thing with subtraction. If I have an equation where two opposite sides are equal, if I take the same away from both of them, it is still true. I want you guys to go ahead and go down to the bottom here where it says solution. So a solution to any equation is any value that makes the equation true. In other words, when I put in a value for an equation that's missing, and it now makes the equation true, that is what we call the solution. We're going to do a little different than they have the lesson set up today in a couple of ways, but we'll get to that as we're doing it. Not quite sure what happened on my page here. Let's go back up here, though. So, excuse me. We're going to use a double number line to start us out in order to start looking at these equations and how this works. So a double number line is a model used to show that two expressions are equal. It helps make visible the equivalent relationship between the expressions. Expressions that are at the same location have the same value. And then the line connecting the expressions is what we call a barbell. So basically makes it, I don't know if any of you guys ever lift any weights or not, but this is kind of like a barbell. You got the two weights on either side with the handle in the middle that you're able to grab a hold of. Okay? So now we're going to use the property of equality stated to write at least 3 equations with the same solution. And then we're going to represent each one on the double number line. So the ones they've given us is the addition property of equality on this page and subtraction property of equality. So you've got both of them on this page. So I'm going to give you an example of each of those to get you started. All it is saying is if I have a baseline where I know that x equals 15, I could add the same number to both sides of it and it will still be equal. In other words, I could go up here and I could say, okay, well, what if I do x plus 5? What is 15 plus 5? 20. So this would represent an additional one that is true. So I know x equals 15, but I also know x plus 5 equals 20 because I add 5 to both sides. Does that make sense for everybody? Okay? We can go the other way, and I don't know why part B didn't show up here, but for using subtraction property of equality, you can do the exact same thing. Instead of starting at our base of x equals 15, I can take the same number away from both and it'll still be equal. In other words, what if I take 5 away from it? X minus 5, who can tell me what's going to go on top of that? 10. Why? Because I take 5 away from both of them. So we could also say x minus 5 equals 10. That would be an additional equation that is equal. Does everybody understand the concept of what we're doing?
Yes.
Okay, so I've given you one example for each. You need to come up with 2 more for each of them. 2 more on addition, 2 more on subtraction. We'll give you guys like 3 minutes. Okay, so here's one of the hard parts on this. There are literally an infinite number of possibilities. So I'm just going to give you a few more, but it all starts with this baseline and adding the same amount to both. So for example, I could have said x plus 1 equals 16. I could have said x plus 10 equals 25. It doesn't matter what it is, as long as you add the same amount to both sides. The subtraction side does the exact same. So as long as I subtract the amount, so I could have said x minus 1 is 14. I could have said x minus 10 is 5. I can use any number I want to, as long as I take the same amount from both sides. Does that make sense for everybody? What?
Yeah.
Okay. Then you're also supposed to model those. So you should have also put them up here. So for example, x plus 1, 16, x plus 10, and 25. So make sure you've done them on both sides. And I did what? X minus 1 and 14. And we did x minus 10 and 5. So that's just some examples. There's any number of them you could have used. Okay, let's go ahead and go to 407. Oh, there was a subtraction. So it was just on the other page. So if you did it on the bottom or there, it's fine. Okay, what if I change up the equation? If I say the equation x plus 5 is 10 is on the double number line, use the property of equality stated to write at least 3 equations with the same solution and represent each on the double number line. So we just changed it up a little bit. Now instead of telling you exactly what it was, we're just telling you some number plus 5 is equal to 10. From that point, you can still add the same amount or subtract the same amount from both to get equivalent numbers. So I'm not going to give you any examples on this one. I want to see how well you guys can do it by yourselves. But it's the same concept. Just realize I'm starting with the plus 5 on the x already. Okay? So do your best. Come up with 3 equations for each and plot them on the double number line. We'll give you guys 5 minutes. Go. Okay. Let's go ahead and talk about these. So again, part of the problem is there can be an infinite number of possibilities. I think a lot of you really got hung up on the fact that it's not just x, that we gave us x plus 5 now. Guys, it doesn't matter what the numbers are. The addition property of equality says if I add the same number to both sides of the equation, it remains equal. If it helps you, you can rewrite this equation as x plus 5 equals 10. So let's just pick a random. Christopher, give me a number between 1 and 10. 3. So if I add 3 to both sides, if I add 3 here and I add 3 here, what do I get? X plus 8 is 13. Guess what? I just used the addition property of equality. I can now put it up here. I added 3, so I now say x plus 8 is 13. Mariana, give me another number between 1 and 10 other than 3. 5. So now if I just add 5 to both sides, it now becomes x plus 10 is 15. So to put it up here, now it's x plus 10, and it is now 15. I hope you're starting to see. It means that I'm randomly picking numbers. Doesn't matter what number I use. No, it doesn't matter. As long as I use the same number on both sides, what's going to happen, Rosalind? As long as I use the same number on both sides of the equation, what's going to happen, Rosalind? it'll still be equal. So if I add 10 to both sides, now I'm at x plus 15, and my top I add 10 was going to be 20. So that is just 3 of an infinite number of examples of how I could use the addition property of equality. Subtraction property of equality is exactly the same. The key is, where am I starting? I am starting at x plus 5 equals 10. So to help keep it easy, Jordan, give me a random number between 1 and 5. 2. If I subtract 2 from both sides, now instead of adding 5, 5 minus 2 is 3. 10 minus 2 is 8. Have I subtracted from both sides? Yes. Even though technically I'm still saying I'm adding here, I took 2 away from both sides. So this is saying x plus 3 is 8. Now the obvious one, instead of adding 5, I could subtract 5, right? So if I took 5 away from both sides, what's 5 minus 5? 0. So that leaves me with what on this side? X. Technically, I could put x plus 0 if you want, because 5 minus 5 is that. 10 minus 5 gives me 5. So I actually know that x equals 5. Now, could I go further? Yeah? What if I went one more? What if I went x minus 1? What would x minus 1 equal? 4. Does this make sense to you guys? Are you seeing that if I add or subtract the same number to both sides of my equation, it stays equal? Yes. Okay? Major concept, guys. You will be using this property of equality all the way through Algebra 2. So all the way through your 11th grade math. What we're teaching you today is going to be applicable. Okay, let's go ahead and go to the next page. Pull out your highlighters again. We're on 408. Guys, quiet down. Okay, again, our highlighters. We now have 2 additional properties, and it's the other 2 major operations that we do. The multiplication property of equality, anybody want to take a wild guess? If I multiply both sides by the same number, it's going to be equal. And the exact same thing with division. When I divide equal values A and B by the same value C, the quotients are equal. One big difference, division property of equality is true only if C is not equal to 0. So the one property I can't use 0 with is division, because we can't divide a number by 0. Okay? So we're going to take a look at these and do the exact same thing we've been doing with the addition and subtraction properties. Okay? So if I have my equation x equals 5 represented on the double number line, use the property of equality stated to write at least 3 equations with the same solution. So, you realize how I just circled that use 3, so I know how many equations I need to do? Amazing what happens when you mark the text, right? Okay, we also need to represent each equation on the double number line. So we got 2 parts. We need to write at least 3 equations with the same solution and represent them on the double number line. So they've given us x and 5. So what number do you want to multiply by? Oh, thank you. I was already thinking ahead to what I was multiplying by. What do you want to multiply both sides by? 2. So if I do this times 2 and this times 2, this gives me 2x and 10. So I can then put this on my number line. So there's x. 2x is across from 10. How many more of those do you need to do? 2 more. 2 more. Then I also need to do the division. Uh-oh, this is going to get interesting. X is 5. What could I divide by? 2. So if I divide by 2, what is 5 over 2? So there's 2 ways to write this. I can either write this as 1/2 x or x over 2, either way. But this one then becomes 2 5/10. So when I write it on my double number line, I'm now at x over 2, and I know that that one is 2 5/10. How many more of those do you need to do? 2. Okay, have fun. We'll give you guys about 5 minutes to do these ones. You got 4 more equations to write and label on your double number line. Okay, so guys, again, 2 keys on this. First key is, where am I starting? In this case, they gave us our equals. Second key is, it doesn't matter what I multiply by, as long as I do it to both sides. So we already did 2. Who picked a different number to multiply by? What'd you do? 3. So now I can do it times 3. Gives me 3x and 15. So on my number line, I now have 3x, 15. Oops, I forgot to put the bar on that one. My bars aren't looking so good today. There we go. Let's redo that. Okay, who can do another number? Yes, Jax. 10. Awesome. X times 10 is 5 times 10. Gives us 10x and 50. So that's going to be somewhere down here. So 10x and 50. Okay. What about dividing? Again, the whole key is I start at x and 5. Any other number I use is fine. So what can I divide them both by? 3. Okay. So that one's not going to work out the greatest, but it's not that bad. X over 3 is 1 2/3. Yeah, 3 goes into 5 once with 2 left over. So x over 3, so I'm dividing it into 3 parts, is going to be 5/3 or 1 2/3.
Guys, quit talking.
Okay. Personally, I would have used 5. So I can do x over 5 is 5 over 5 or 1. So I can do x over 5 and 1 as another one of my points. Do they all have to be exact like that? Could I use like 2/5? Yeah? Okay. So the key though is I have to use the same value on both sides. So they started us easy again. They gave us just straight up what x equaled. Let's go to our next page. Now they're going to change up our equation a little bit. So if I look at 1/2 x equals 10 on the double number line, I use the property of equality stated to write at least 3 equations. So Giselle, how many do I have to write? And what else do I have to do with them? Represent each equation on the double number line. So 2 parts, write at least 3 equations, and represent them on the double number line. So we're about to head to lunch, but we'll try to get at least 1 or 2 of them done now. One key, I would rewrite this as 1/2 x equals 10 to help you understand what's happening. And then just pick the number that you want to multiply by. Given this, I would recommend using even numbers. It will make it easier for you. Okay? And on the division side, I'll give you a hint real quick. Actually, I'll do the division when you get back. Okay? So try to write your 3 multiplication equations now. Okay, again, guys, the whole idea in this is I'm multiplying both sides of my equation by the same number. Since I started at 1/2, the math will work better for you if you use an even number, because half of that even number is going to give me an even number. So, for example, to me, the easiest one would have been both these times 2. Because 1/2 times 2 is 1/1, which means this is just x equals 20. Then I can go to my chart and I would say x 20. Because what's 1/2 times 2? 1. What's 1 times x? X. Okay? X is 20. We just solved for it. Okay? I could also multiply by 4. So if I did times 4, that's 4 over 2, or 2x equals 40,
Quit talking.
which would be somewhere out here. And I could also do times 6, or times 6 would give me 3x is 60. Should be all the way out. 3x and 60. The other side, now I needed to divide, and here's where it gets a little trickier as far as the math goes, because now I have 1/2 x is 10, but if I divide this by 2, I now have 1/2 divided by 2. How do we divide fractions? Or whole numbers in this case? Jax? Keep, change, flip. That's our process. I keep the first number, change it to multiplication. I flip the second number. So it's now 1 times 1 is 1, 2 times 2 is 4. So 1/2 divided by 2 is actually 1/4 x. 10 divided by 2 is 5. So my next one would be 1/4 x and 5. Then we can do 2 additional ones. I would probably just continue going by powers of 2 again. So 1/2 x divided by 4 gives me 1/2 divided by 4 over 1, or 1/2 times 1 over 4. Keep, change, flip gives me 1/8 x, and 10 divided by 4 is going to be 2.5. So it looks something like this: 2.5 and 1/8 x. Then we can do another one. If I did 1/2 x divided by 6 is 10 divided by 6, so 1/2 divided by 6 is the same as 1/2 times 1/6, or 1/12 x. 10 over 6 is going to give me 1 2/3. So 1/12 x, which is going to be somewhere down in this area, and 1 2/3. Are you starting to see some of the patterns? The big key, guys, it literally doesn't matter what I do to both sides of my equation, it stays equal. As long as I use the same number and the same operation on both sides of my equation. Okay, so we're actually going to go back. I want you guys to go back now to page 401. 401. Page 401. Okay? Here is your task. Rewrite each number as an addition, subtraction, multiplication, or division expression. So rewrite all of these numbers using all of these operations. Okay? So I'll give you guys like 2 minutes to do all these. Okay, guys, I'm seeing a lot of confusion, so let me help you. If I rewrite this, 20 plus 4 is 24. 28 minus 4 is 24. 6 times 4 is 24. 48 divided by 2 is 24.
Oh my
Have I used addition, subtraction, multiplication, and division to get that number? Yes. Do you understand what we're doing?
Yes.
Okay, keep going. Also, guys, I want to get to the next part, so we're going to kind of rush through this. Because, sorry, but this part is not as important as what we're about to do. So, using addition, how could I get 1/2? 1/4 plus 1/4 is 1/2. Using subtraction, 1 minus 1/2 is 1/2. Multiplication, 2 times 1/4 is 1/2. How do I get 1/2? 1 divided by 2 is 1/2. It doesn't have to be these. Literally, whatever you wrote is fine as long as you get to 1/2. 0 is even easier. 3, actually, I have to add negatives. 3 plus -3 is 0.
Or 0 plus 0.
You can do that one. Or we could do 4 minus 4 is 0. I can do any number. 28 times 0 is 0. The key on division, my 0 has to come first. I can't have 0 second in division. So 0 divided by 5 is 0. 100. 50 plus 50. I could do subtraction, 110 minus 10. Multiplication, I could do 50 times 2. Division, 200 divided by 2. So if you didn't have answers written down, make sure you copy something down so you've got it. But what is the whole goal in this exercise? Is to show you I can get to any number using any of the 4 operations, correct?
Yes.
Does everybody get that concept?
Yes.
Okay? So here is our big learning point. Guys, listen. The only thing what you're talking right now is Miss McShan. The whole concept on this, it doesn't matter what operation I do. I can get to any number using any operation. So, we can write the same value more than one way. Write 3 different expressions equal to 4. So, who can give me a way to get to 4? 2 plus 2. Awesome. Does it matter if my 4 is on the left side instead of the right? No. Triton? 2 times 2? Who's got another way? 1 times 4? Awesome. There are an infinite number of ways we could get to 4, correct? Yes. Now, write 3 different expressions to show equal to 4 plus 5. So the easy way would be just to add them. What's 4 plus 5?
9.
Would that be equivalent?
Yes.
Yes? Could I write it another way? 9 plus 0? Is there another way I could do it? 3 times 3? Are all those equivalent?
Yeah.
So, am I limited to one operation? No. As long as I can get to the number, I'm good. Now, let's go ahead and go to the next page, because here's where kind of the rubber meets the road. And we're actually going to skip this whole piece. I want you guys to go to 404.
Quit talking, please.
No, I don't. I want you to go to 405. Go to 405.
405.
Okay, I'm going to give you guys a way to solve these equations. So add this to your notes. We're on page 405. Step 1. Circle the variable. Step 2. Draw a line through the equal sign. Step 3, find the number with the variable. Step 4, do the opposite operation with that number on both sides. So I know it might take a couple of you a little longer to write this. That's okay. I'll be honest. When I first started teaching math, this was one of those that really enlightened me as a math teacher. As a math student, I honestly was not the best student because I was the kid, like Christopher, who basically figured out how to do it all and then just did it all and then would listen to kind of what the teacher said, pick up anything I think I might need along the way. Because once I figured out how to do it, it was no big deal. Okay? So when I started teaching, that really started to hurt me because I was like, well, I know how to do this, but then figuring out how to teach it became problematic because I basically just did it all in my head and understood what I was doing. And even once I started to teach it, it took me a while to come up with this. This was actually a 3-year process, teaching and reteaching, figuring out how I could reach everybody to get it to work. But what I found is this works really well if you will do this, whether you're at Christopher's level or, I'm not going to embarrass anybody, but someone who doesn't quite understand this stuff. Okay, Lucas is volunteering. So if you're at Lucas's level where you really can't hardly even understand what's going on, if you will follow the steps, it becomes very easy. So the first thing I want you to do is replace this blank with an X, because X is our most common variable. So we're just going to rewrite this. And I'm going to say 31 plus 67 equals X plus 12. Okay? Let's look through our steps. Our first step is circle our variable right here. Draw a line through the equal sign. Everybody should be able to do that. Am I asking a lot of work? No. Step 3, to help you understand it, says, find my variable. And honestly, guys, this is why I started circling the variable. Initially, I just started with the line, but people weren't able to figure out what number was with the variable. But circling it made it easier because it draws your attention. So can everybody see what number is with the variable? 12. What operation is it? Addition. So here's the key. I need to do the opposite operation with that number. So what is the opposite of adding 12? Subtracting 12. But I need to do that to both sides of my equation. Why? Because I now have 12 minus 12. What does 12 minus 12 equal? 0. What does x plus 0 equal? X. Any number I add 0 to stays at that number. 100 plus 0 is 100. 2 plus 0 is 2. Doesn't matter what the number is. If I add 0, it's that number. So on this side, I now have a little step. I should do this first. 31 plus 67 gives me 98.
Wow, I love your notes.
If I take 12 away, it gives me 86. So I've now solved my equation. X is 86. So what number did I add 12 to get the same thing as 31 and 67? I added 12. Does that make sense for everybody? Now, we've already shown you it doesn't matter what operation I do, right? As long as I'm doing the same operation with that number on both sides, my equation stays the same. So let's go to page 410 or 411. This is your homework. Okay, just a couple notes. Note 1. They gave you the properties that you're using for your journal entry. Makes that easy. Step 2. here's what we'd like you to do. Instead of the blank, put an X in every one of these. And then you're going to just solve for X. In this case, they've already given you the solution. Yay! Easiest homework problem you'll ever do. Oh, unless you're packing up and not doing what I tell you to do, right, Eva? Okay, on your second page. This one, they're just asking you that we just did this. All you're doing is using addition and division properties to rewrite 3 equations, okay? Any questions on your homework?
No.
Guys, should be pretty easy for you.